In this video, we'll be looking at central angles for circles, as well as arc measure and arc length. And we'll be looking at the differences with these things and making sure we understand exactly what is what. All right, so if we have a circle, and we have the center here, let's call our circle B. So let's make that center at B. And we create two radii. We have just made an angle. So let's say this is A, B, and then C. So we have just made a central angle. And it's a central angle because of what you probably think, because we have the angle in the center of the circle. So how we would write this is angle ABC is the central angle, or is a central angle, because there are several. Of circle B. And remember, we write circle B like that. All right, so a couple things we should know about the central angle. And the most important thing that we should know is that all the central angles put together, the non-overlapping central angles, will be equal in measure to 360 degrees when you add them up. So let's say, for example, I have one central angle here. Let's call this D. So now we have three central angles. We have angle ABC. We have angle ABD. And we have angle DBC. So those three angles, this one, and this one, when you add them all up, you should get 360 degrees. So we can actually do an example here. Let's say that this is 95 degrees. Let's say this central angle is 130 degrees. And I want to find out what x is. I will go ahead and just plug into this formula. It's not really a formula, it's just a fact. So ABC, 95 degrees, plus ABD, 130 degrees, plus x, which we don't know yet, is 360. And we could go ahead and solve that. So we have 225 degrees plus x degrees gives us 360 degrees. And finally, we subtract 225 from both sides and we get that x is equal to 135 degrees. All right, so we can use this information for a lot of things, and we'll see some of what we can do with this a little bit later. All right, so now we're going to be looking at arcs. So an arc is defined as a portion of the circle defined by two endpoints. And the way an arc is created is by making a central angle in our circle. So if we have a circle, if we have a center here, and we have a central angle here, and let's put back the same letters we had before. I think it was ABC. All right, so if we have a central angle there, that central angle creates two arcs. So we have actually three types of arcs. In this circle, we have two types of arcs, and I'll show you the other type in another circle. All right, so we have in blue, outlined in blue, we have a minor arc. We know it's a minor arc because it is less than 180 degrees in measure. It's the shorter arc, or the smaller arc of the two. And in black, which was in black before, so out here, we have what we call the major arc. So once you have that central angle, you're going to have a minor arc and a major arc. Or the other option is this. Our central angle could go straight across here. So our central angle could actually be 180 degrees, in which case our two arcs, or major arc, so I'm going to, there's no longer a major arc because they're both the same size. So instead of having a major arc and a minor arc, we now have two arcs that are called semicircles. So again, either you have a central angle creating a minor arc and a major arc, or you have a central angle of 180 degrees, which creates two semicircles. All right, so here's the tricky thing, though, I think. An arc measure is the same measurement as its central angle. So for example, if this angle here was 85 degrees, let me write that down. If this angle here was 85 degrees, then the measure of that minor arc is also 85 degrees. Blows my mind. All right, so if ever you're asked to give an arc measure, and I'm giving stress to that word measure for a reason, whenever you're asked to find an arc measure, you're really finding the size of the central angle that's associated with it. Okay, so to make sure everything that we discussed is absolutely clear, we're going to go through an example. But before we do, we really need to know how to name our arcs. So if we have a minor arc, so in this case, we have a minor arc at HJ. So if we have a minor arc, we name it HJ conveniently, but remember that HJ is really the length of a segment, and that's not what we're interested in right now. So in order to say arc, you put a little arc over it. And in order to say we're interested in the measure of this arc, well, we put M before it. So now here I'm saying, what is the measure of arc HJ? Or the measure of arc HJ is equal to. All right, so now that we know how to name our minor arc, let's look at how to name a major arc. So here we have a major arc over here. So the other side of HJ, instead of HJ, it's over on the other side. So we actually have to throw in an extra letter to make sure that whoever is reading our work knows that we're not referring to HJ, but we're referring to what goes around in the other direction. So we can say HGJ, or we can say HLJ. It doesn't matter which one we choose, it's fine either way. So a major arc is HGJ. So semicircle we treat in the same way, and we have a semicircle right here, and we have one right here. So we need three letters to name a semicircle. So I'm going to pick the bottom one for now and work with the measure of GLJ. Arc GLJ. All right, and there are other minor arcs and other major arcs and other semicircles, but I'm going to start off with the first minor arc because I just wanted to show you initially how to name these arcs. So measure of arc HJ. Well, we know that the measure of the arc is going to be the same as the measure of the central angle, and we know that this is a straight line here. And it looks like we have a linear pair here between 122 and this angle here, which means that that angle here is 180 minus 122. All right, 180 minus 122, which gives us 58 degrees. So the measure of that arc is 58 degrees. Is there another minor arc here? Yes, there is. There is arc GH, and even though it is bigger, GH is bigger than the arc that we just looked at, it's still less than 180 degrees, so it is still a minor arc. So the measure of GH, we only need two letters because it is a minor arc, was given, so we don't have to calculate anything. It's 122 degrees. All right, so as far as our major arcs are concerned, we have HGJ. So we already know that HJ is 58 and HGJ is everything else in the circle. So HGJ we can find by subtracting, I'll just write it in here, subtracting or 58 from 360. And there are other ways to do it. That's just the way I chose. And so we get that HGJ is equal to 302 degrees. Now our other major arc goes with, or GH, but it's the other side. So GH is here. So the major arc that goes with it goes the other direction. So it's GLH. We could also say GJH, doesn't matter. So measure of GLH is everything outside of that 122 degrees. So our circle is getting a little crowded, so I'll do it down here. It's 360 minus 122 degrees. And we get that GLH is equal to 238 degrees. That's the measure. And finally, well, semicircles are super easy. They are always 180 degree in measure. So there is another semicircle, so I'll just write that down very quickly. We have GLJ as well as GHJ. And again, that is going to be 180. So that's how you do arc measure. It's really the same as the central angle, in opposed to arc length, which we will now quickly explore. Okay, so we already know that the measure of angle ACE is equal to 60 degrees. That's the central angle. We also know that the measure of arc AE, that's a minor arc, is also 60 degrees. Remember, they're going to be the same thing. But what we don't know is the length of arc AE. And that's a different question. Measure of the arc and the length of the arc are two different questions, and it's super important that we know this. So length of arc, I don't have to write the word arc. Let's fix that. Of arc AE. All right, in order to find the length of an arc, we need to remember that it's an arc length is actually a fraction of our circumference. So what I'm asking for is if you had a perfectly curved ruler, a ruler that could curve around any circle, I'm asking for the length, and I should use a different color so you know the difference between what I need and what's already there. All right, so if I ask for the length of arc AE, I'm actually asking you to measure what I just traced in blue. All right, and we can't do this right now because we don't have a radius, so we don't have a circumference. So let's say the radius, is 5 centimeters, which means that the circumference, and you should know this from a previous lesson, the circumference is 2 pi r, which means the circumference is 2 pi times 5, or 10 pi centimeters. All right, so the circumference is 10 pi centimeters, and our arc length is a portion of that. And what is the portion? Well, the central angle that we're looking at is 60 degrees, or the arc measure is 60 degrees. The whole circle is 360. So that is the portion of the circumference that we're looking for. So we can put one over the other, and we multiply by our circumference, which is 10 pi. And when we're done with that, we should get, let's do a little thing here, we should get 10 over 6 pi, reduced further to 5 over 3 pi. All right, and that's how you find an arc length. Super important that you know the difference between arc length and arc measure. All right, that's it for now.